Hi students, Professor Gray here. We need to talk about temperature and temperature scales. So, we all pretty much intuitively know what temperature is, but in science, the definition of temperature is a measure of the average kinetic energy of particles in a sample of matter. And this is expressed in terms of units or degrees designated on a standard scale. So, what on earth am I talking about? Well, kinetic energy, that's the energy of movement. And if we take a look at the atoms over here, in the cylinder where it says hot, that's showing you that those atoms have a lot of energy, and that means that they're moving around like crazy. And because they are moving around faster and bumping into each other a whole lot more, they try to take up a little bit more space like humans do when they have a whole lot of energy. If you think about if you go to a dance club and there's somebody with crazy energy out on the dance floor flinging their arms around, people tend to stay a little bit further away from them. So that's what we see with the atoms there too. So lots of energy moving around faster, taking up a little more room. Now, if we have less energy in the system, what we experience as cold, what happens is the atoms there have less energy, and so they're not moving around as much. And they're shivering and saying, oh my goodness, it's really cold, we need to snuggle together. So they get closer together, and you can see there that they're taking up less space. So the second part of this slide says it's a physical property that determines the direction of heat flow in an object upon contact with another object. So that brings us to this picture down here. So right here it says the temperature of object A is greater than the temperature of object B. So when they come in contact, we'll have heat energy transfer from object A to object B until they come into thermal equilibrium, until they come to the same temperature. Now, that means that cold doesn't really exist. It's just the absence of heat, which probably makes you think, what? I feel cold. I know it exists. Yeah, that's true in real life. But what you're feeling when you walk outside and it's really cold is you're feeling the absence of heat in the air, and you're feeling yourself transfer heat to the air. So that's what you're feeling there. Now, how do we measure temperature? Well, with a thermometer, right? But what I'm talking about is different scales. So we have Fahrenheit, Celsius, and Kelvin. So the rest of the world measures temperature in Celsius, so degrees C. That's exactly the same thing as centigrade, and they're both degrees C. And in the United States, we tend to do temperature in Fahrenheit, which is kind of a wonky scale, and it even has a weird spelling. It looks like Fahrenheit. And there's another scale called Kelvin. So we tend to use Kelvin in the laboratory when we're looking at really low temperatures or something really complicated having to do with thermal energy. All right, so how are these scales related? Well, if we look at thermometers, what we will notice first right here is the temperature where water freezes. So most of us know that the temperature where water freezes is 32 degrees Fahrenheit. And that is the same as 0 degrees Celsius. So Celsius already makes a whole lot of sense because water freezes at 0 degrees. That sounds like a cold temperature. So, yeah. And in Kelvin, water freezes at 273 degrees. And actually, I shouldn't say degrees because there's no degree symbol next to Kelvin. It's just 273 Kelvin. And if we look up above, we can see that water boils at 100 degrees Celsius, which makes total sense. Water freezes at 0 and it boils at 100. That's really easy to remember. And if you didn't have this picture here and somebody asks you, what temperature does water boil at in Fahrenheit, you might be standing there going, I have no idea. But it's 212 degrees. So you can see how Fahrenheit is a little bit more difficult to use than Celsius. So water freezes at 32 and boils at 212. That sounds kind of random there. It just makes a little more sense to us because we're used to it, but the rest of the world doesn't make a whole lot of sense. Now, where water boils is 373 Kelvin. Again, the Kelvin doesn't have a degree symbol next to it. So this right here is not a typo. That is on purpose. There's no degree symbol there. All right, so another thing that we need to notice about the different temperature scales is that between water freezing and water boiling, for both Celsius and Kelvin, what we have is 100 degrees. So there's 100-degree difference right there. That means that the size of the degree for Celsius and Kelvin is the same. There's 100 Celsius degrees between freezing and boiling, and there's 100 Kelvins between freezing and boiling of water. Now, Fahrenheit, there's 180 degrees Fahrenheit between water freezing and water boiling right there, 180. That means that the degree size in Fahrenheit is smaller than the degree size in Celsius and Kelvin. Now that sounds really weird because it looks like 180 is the bigger number. 180 is bigger than 100, but we've got the same distance right here, and we can fit 180 Fahrenheit degrees in that distance, whereas we can only fit 100 degrees between water freezing and boiling in both the Celsius and Kelvin scales. So the degrees in Fahrenheit are smaller. We can put more of them in the same space than we can in the same space for Celsius and Kelvin. Okay, so if we go all the way down here, what we'll notice is 0 Kelvin, and that's where we have absolute 0. So we don't have a whole lot of thermal energy down there, and we haven't been able to reach absolute 0 in the lab yet, but we have come really close to it. Over here on this side, what you'll notice is equations for going between the different temperature scales. So if you would like to have your temperature in Fahrenheit, but you have it in Celsius, what you do is you would take your degrees in Celsius, multiply it by 1.8, and then add 32 to it. If you want your temperature in Celsius, but you have it in Fahrenheit, what you would first do is take your temperature in Fahrenheit and subtract 32 from it. And then you would divide that answer by 1.8. Now, a lot of books and teachers do 5/9 and 9/5, but we're not going to do that. We're going to do multiply by 1.8 and divide by 1.8 because I like that version better. Okay, so how do we get between Celsius and Kelvin? This is really easy. If you have your temperature in Celsius and you want your temperature in Kelvin, all you do is take your temperature in Celsius and add 273 to it. So you see that right here? If your temperature in Celsius is 0 and you want to get to Kelvin, you just add 273 to it and there you are. Okay, again, if your temperature is 100 degrees Celsius and you want that temperature in Kelvin, you just add 273 to it And there you are, 373 Kelvin. Now, if you have your temperature in Kelvin and you want to go back to Celsius, you just do the opposite. You subtract 273. So if we have our temperature in Kelvin, right there, 273 Kelvin, and we want to go back to Celsius, we just subtract 273, and there we are at 0. Or if we have our temperature in Kelvin, it's 373, and we want our temperature in Celsius, we subtract 273, and there we are at 100 degrees Celsius. Now, if we want to get really specific, we can add a 0.15 to the end here. But I will let you guys go on to Chem 1A and Chem 1B before you have to use the 0.15. We'll just stick with 273. Now, why Kelvin? Well, there was this guy, Lord William Kelvin, and he did a lot of thermodynamic work, so we named the temperature scale after him. He was the one that calculated the correct temperature, minus 273.15 degrees Celsius for absolute zero, or 0 degrees Kelvin. Exactly who you want to see on one of those dating apps, right? Swipe right on this dude. Woohoo! Okay, so let's do some problems. So it's 35 degrees in London, and we want to know, is it probably winter or summer? So those of you who are really comfortable with the Celsius scale, you might be able to pick this out right away, but those of us who only know Fahrenheit, we'll have to go ahead and do the math on this. And then we want to know what the temperature is in Kelvin. So what you're going to want to do is you're going to want to write your equation out first, because then it gets in your head how to do this, and it makes it a lot quicker for quizzes and tests, and that's better for you. So if we want a temperature in Fahrenheit, we have to multiply our Celsius temperature, which is 35, times 1.8, and we add 32 to that. That is going to give us 95 degrees Fahrenheit. Now, 95 degrees Fahrenheit in London is definitely summer. England tends to be a cold place. A lot of people don't even have air conditioning, which sounds really strange for those of us who live in Southern California, because sometimes we have to turn the air conditioner on in February when we get a heat wave. But yes, 95 degrees in London and people are dying. Oh my goodness, it's so hot. Here in Southern California, we're like, ha, try 115. All right, so what is this temperature in Kelvin? Well, that's an easier one to solve. So temperature in Kelvin, we take our degrees Celsius and we add 273 to that. So that would mean we'd have 35, and we would add 273 to that. And what we would get is 308 Kelvin. Okay, so number 2, you're feeling sick and you decide to take your temperature. Your thermometer, which only reads temperatures in Kelvin, because we all have a Kelvin thermometer sitting around our house, right? Says that you have a temperature of 312 Kelvin, and we want to know, do you have a fever? All right, so we want to go from Kelvin to Celsius. So we have degrees Celsius equals Kelvin minus 273. So we write out our equation first, just to keep reminding ourselves of what it is, and that way it gets on our brain. And we have a 312 minus 273, and that gives us 39 degrees Celsius. Now, at this point, people who are used to degrees Celsius might be able to answer the question if they know what normal body temperature is in Celsius. And that's going to be an average normal body temperature because different people have slightly different body temperatures, and we have different body temperatures at different times of the day. And gals have different body temperatures at different parts of their cycles. And the guys right now are covering their ears, going, la 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 la, I don't want to know about that, but now you do. Okay, so for the rest of us, we've got to go to Fahrenheit because most of us know that the average normal body temperature in Fahrenheit is 98.6. And of course, there are articles coming out left, right, and center saying, that might not be exactly right. But until we figure out a new normal, we're going with 98.6. So we have degrees Celsius times 1.8 plus 132. So we have 39 multiplied by 1.8 plus 32. And that is going to give us 102.2 degrees Fahrenheit. Or if we follow the significant digit rules, so we have multiplication and division rules first, and then we would take that answer and add it to 32. So then we would switch over to addition and subtraction rules. That would give us a temperature of 102 degrees Fahrenheit. And we haven't completely answered the question yet because the part of the question that we haven't answered right there is, do you have a fever? So if we're supposed to be at 98.6 degrees Fahrenheit and the thermometers are reading 102 degrees Fahrenheit, do we have a fever? Yes, you're going to need to take some Tylenol there. Okay, so that is the temperature lecture. I will see you in the next lecture. Bye-bye.